Now, for an event to be classified as binomial, there are 4 conditions you have to satisfy. 4 conditions. And if you know this is actually binomial, then we have equation that will give us the answer. I don't have to list all the combinations. The 4 conditions you have to satisfy is, or are, you must have a fixed number of trial. Fixed number. That's the first condition. In my programming language, we just wrote a program that you can't get out of the loop till you get 10 correct answers. Not in a row, but 10 correct answers. Is that a fixed number of trial when you run it and I run it? Is that the same number? No. It might take me 20 tries before I get 10 right. It might take you only 10. So that's not a fixed number. But when you take a quiz, usually the quiz has 20 questions on it. That's it. Everyone gets the same quiz, 20 questions. That's a fixed number. Or we're going to repeat this experiment 13 times. That's a fixed number. So that's the first condition. You must have a fixed number of trial. The second condition, each one of these trials must be independent of each other. Meaning going back to a quiz. If this is a quiz, and if question 7 requires that you take the answer from question 6 and use it, then that's not binomial. Why? Because if you get question 6 wrong, guess what happened to question 7? It's going to be wrong, so that's dependent. So what happens in the previous questions does not affect the answer on the next question. They have to be independent. The next one, they must have 2 outcomes or reducible to 2. And we call the outcomes success and failure. And I don't want you to think success always represents something nice and failure something bad. Success could be somebody dying of cancer, if the event about cancer. If the event was we're studying people wearing glasses, success might be somebody wearing glasses. You know, if you're wearing glasses, that's the last thing you want to wear. You don't want to wear glasses. You'd rather not have them. So success could be anything. And the last option is the probability of success must remain the same. The probability of success must remain the same through the whole study, the whole trial. If it's a test, the whole test. So let me give you some sample quizzes here. Tell me yes, no. Does this fit binomial or not? This is the first quiz. This is the question, exactly the way the question I'm going to write it, just like that. There's a reason why I make it that line instead of writing a question. Does this quiz represent binomial experiment? Well, let's see. Go ahead, Scott.
Since it has 3 options, it's not reducible to 2.
Well, it is reducible to 2. Because if this is a question, notice you have a fixed number of trial? Yes, we have 3 questions. Must be.
I mean 3 answers.
Oh, then that's, yeah, option 4. I don't know if you're looking at 4. But
it could either be right or wrong.
Yep, that's why I'm going to go with them, is be correct and incorrect. So it might be 3 answers, but I'm going to reduce them to correct and incorrect. So that's why it's actually option 3 is okay. You have success and failure. Success getting the correct answer. It might be 3 answers, only 1 correct and 2 wrong. Hopefully there's only 1 correct answer to each one. So yes, fixed number of trials, yes. I made this squiggly line because now whatever you answer to this doesn't affect that one. So that's why independent now, yep, that is independent, because I have no idea what the questions are. Nobody knows. and we have two outcomes. Well, they're not two. There's three outcomes here, 3 and 2, but you can reduce them to two outcomes, as Trent said, success and failure. But here's where they fail. The probability of success must remain the same. What is the probability of guessing the correct answer here?
1/2.
1/2. What's the probability of guessing the correct answer here?
1/3.
1/3. That's not the same. It's not a binomial. Now, if I change the question to this one, for question this one. Does this fit binomial? So not binomial here. Why? The probability of success not the same. That's this one. What about this one? Is it binomial? It is binomial. Why? We have a fixed number. Rule 1 passed. Must be independent. Yes, they are. Must have two outcomes reducible to 2. Yes. Correct answer, incorrect. And the probability of success, assuming only one correct answer to each question, is the same. So that's a binomial. So if you want to make probability distribution table, you got to do what we did last time. Figure out how many ways can you have one correct answer, two correct answer, three correct answer. So to create a probability distribution table out of this problem now, X is the number of correct answers. And the probability of X. You can have 0 correct on that test. You can have 1. You can have 2. You can have 3 and 4. And that's it. That's all the possible outcome. You could never have more than 4 correct answers. To get 0 correct, there's only one way. 0 correct, that means what? Wrong, 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 and wrong. What's the chance of getting the wrong answer? 2 out of 3. 2 out of 3. 2 out of 3. 2 out of 3. 16 out of what? 81? We can do the math on that. 16 divided by 81. That's almost a 20%, 0.20. 20% chance, or 19.7% chance. 1 correct. That means could be correct, wrong, 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 or wrong, correct, wrong, wrong, or wrong, wrong, correct, and wrong. And the last option, the first 3 are wrong and the last one is correct. There are 4 different ways. The good news is, because all these have 3 answers, once you find the answer to one, the other one is going to be exactly the same. So let's find the answer to one. To one of them wrong is 2 out of 3. 2 out of 3. 2 out of 3. 1 out of 3. That's 8 out of 81, right? 8, not 81. And how many of these choices do we have? How many of these sets do we have? Times 4. What's 4 times 8? 32 out of 81. I'll put around it closer, 0.198 here. I'll go 3 decimal places. So what's 32 over 81? I drew mental block, looking for the 3. What'd you get there? 0.395? Yep. And to get two correct answers, I can do the same thing. But the reason we're looking at binomials, so I don't have to list them. So is there an easier way I can get to the answer without having to do it? Now, when you look at this example, n is the number of questions, which is what in this case? 4. There are 4 questions on that test. To find the answer to each one of these, we're going to use this equation. I'll explain what the pieces are. It's n cx times p to the power of x times q to the power of n minus x. P here represent the probability of success. For this example, success for us is guessing what? The correct answer? So that's 1 out of 3. Q is the probability of failure. And failure, what's the probability of that? 2 out of 3? I know I have an extra letter here. And what about x? What's x then? X is the number of correct answers, right here. And if you want to know really if that's true or not, for the first one, x is what? 0. So this is 4C0, and that will tell you how many choices, and that's a 1. There's only one set of these. And how'd you come up with that number? We did 2/3, because P is success, P is 0, so 1/3 to the power of 0, times 2/3 to what power? 4 minus 0, which is what? 4? C0, that's a 1, and this is the probability, 2/3 to the 4th. Isn't that what that number is? That's how you come up with that number. The next one correct answer. This is what? 4C1 times 1/3 to the 1 times 2/3 to the power of 4 minus 1, which is 3. And if you look at that, you see 2/3 how many times? 3 times, and 1/3 once. And 4C1, that's a 4. That tells you there are 4 cases here. So this one tells you how many cases exist, and this is the probability of each one of these cases. How many sets of these? So to get the answer for the next one is 4C2, 1/3 squared, 2/3 squared. 4C2, isn't that a 6? 1/3 squared, that's 1/9. 2/3 when you square it, that's 4/9. 6 times 4 is what? 24? And if you want to divide them, 24 divided by 81.296. The next one, 3 correct answers. 4C3, 1/3 cubed, 2/3 to the first. That's a 4. 1/3 cube is 1/27, and this is 2/3. 8/81. .099. And the last one to get 4 correct answers, that's 4C4, 1/3 to the 4th, 2/3 to the power of 4 minus 4, which is 0. That's a 1. This is 1/81. and this is a 1. 1 out of 81 chance. Which is 0.012. Now when I add these numbers, the answer should be close to a 1 there. Might not be exactly 1 because I rounded, but if I add these fractions, the answer is 1. That's 81 over 81. But when you round them, you're a little bit off there. 0.198 plus 0.395 plus 0.296 plus 0.099 plus 0.012. Oh, end up with 1 actually, with the rounding. I got a 1. No fudging the numbers. But a lot of times you end up with 0.99, 0.98, 1.01. That's fine. Now also you can find Q by going 1 minus P. That's also Q. 1 minus P. So let's take an example. Another example. I'll make something up. I don't want success always to be something nice. Okay. Let's assume you go on vacation. Spring break is coming up. Here we go. This is an airplane. Small plane. And this plane can hold only 10 passengers. Small plane. Well, here's what Southwest says. Only 85% of the people, only 85% of the people will show up for their scheduled flight. So when they have a plane that holds 10 people, they go, well, 85% of them are going to show up. Let's say this flight is going to, I don't know, Orlando, Florida. That's a popular place to go to, or Cancun, spring break. I can sell a seat today for $700. So what they do, they might sell 11 tickets for that flight. Little plane, you're probably not going to go from Bradley to Cancun, and it's not worth it because it's going to be in the air so much. But they sell 11 tickets and hoping only 85. This statement is true, and none of them will show up. Now you get the money from the next person. And that's why sometimes you go and say, how can the plane be oversold, overbooked? They go, we need volunteers, we overbooked the flight.
I was just going to say that. I was going to Florida and they had an overbooked flight.
Yep.
They were trying to offer people
Free round trip tickets.
$500 in a hotel overnight to go into the next plane.
Yep. Rich and I were actually in California at a conference, San Francisco, and the plane was full. And they wanted some people to give us free round trip tickets to come from California to here if you just go the next flight. Rich goes, well, no. I said, well, are you crazy? We're in San Francisco. What's the rush to get to Springfield, Massachusetts? I'm staying there. So I convinced them to stay. We stayed there. Each one got a round trip ticket. Now that second plane was full. They were offering 2 round trip tickets if you take the red eye flight. And he goes, no. I said, there's the keys to my car. I sat in the plane thinking about it. So you know what? There's the keys to my car. You go home when you get home. I'm staying. I'll just rent a car here and I'll stay and come home with 3 round trip tickets.
Yeah.
By the time I went back, somebody else took that offer, so I lost on that deal. But I only came home with 1 round trip ticket.
Yeah, they offer big stuff.
Yep. And that's because they do that. It doesn't really cost them anything because if they're full, we'll put you on the next flight. We'll give you another free trip next time. Next time the plane is still empty, we'll give you that.
And they keep going up too,
Yep.
and nobody takes it.
So let's see what happens here. If you have 10 seats, it is possible. We're going to define people showing up. Success here as show up for your scheduled flight. So you could have how many people showing up for their flight? It could be actually 0 of them will show up. Maybe it just happens to be the same family and they have an emergency and they decide not to go. It is possible only one person will show up for the flight. 2, 3, 4, 5, 6, 7, 8, 9, and 10. Well, if you sell 11 tickets, how many people will show up? Could be up to 11, right? So if you decide to sell 11 tickets, so let's say we sold 11 tickets. Let's see what the chance all 11 will show up. So your chance from 0 to 11. And we're going to find the chance of that happening. The chance only one is nobody will show up for that flight, assuming they're different people, it's almost a 0. But the way you find the probability for that, what's n equal to? How many tickets do we sell here? 11. So what's 11? C0 times success. Success is showing up for your ticket. Success here is what? 0.85. So the equation I'm going to be using, n is 11, cx times p, which is success, 0.85 to the power of what? X times 0.15, failure is 1 minus 0.85, which is 0.15, to the power of what? 11 minus x in this example. That's the equation I'm going to use. So for this one, x is 0. 0.15 to the power of 11 minus 0. Here's my calculator. I can write the whole thing in it. 11, math and probability. Where's math here? On this one. Does anyone see math and probability? Math. Oh, math. Here we go. Probability. NCR. Can you see the NCR?
So it's a combination.
Yep, it is. 0 times 0.85 to the power of 0 times 0.15 to the power of 11 minus 0, which is what? 11. So here's the chance. 0 plus 0.00000, 9 zeros and 8. I said 0 plus, that means not really 0. If you just write 0, that means this will never happen. Impossible. It could happen. The probability is close to 0. That's what 0 plus means. Let's do it for 1. I can cheat here, retype that expression, go higher, and take the 0, make it 1, 1, and make that a 10. So for the next one's 11, C1, 0.85 to the 1, 0.15 to the 10. And again, that's still 0 plus. The next one, X is 2. So the next one, X is 2. That's still almost a 0. I have 5 zeros, then a 1. Then X is what? 3. So let's try that and see if we can start putting numbers here. Still almost a 0. X is 4. Four, 7. Well, this is 0.0003. X is 5. Only 5 will show up. Notice we always increase this by 1, decrease this by 1. 5, 6. 0.0023. X is 6. Six, 5. 0.0132. There's a 1% chance that only 6 of them will show up, or exactly 6. 7 of them. So the next one, 7, 4, 0.0536. I'll do the 8 without having to write it down. Same idea. 8, 8, 8. Uh-oh, I screwed up there. That was not here. 8, 8, and a 4. 0.0228. Is that what you got?
Mm-hmm.
The next one. 9, 3. 0.0429. How about 3 all? For 10. 10. Times 0.15 to the power of 2. I got 0.0487. And for 11, what do we have? I'm start cross-eyed now. I'm seeing things. I have to think about, like, oh, which number? I'm putting me to sleep. The last one should have been a 0, right? I don't know if I have something. It should have been a 0, the last one. So I don't know if I left anything out. I hope I get the right numbers. So the last one should have been You can double check these numbers. I'm not optimistic.
Should those, all those add up to 1?
They should eventually, but I think I'm missing a number.
Gotta be something that we-
Yep, because I know this one is okay, that one is not.
Is that combination thing the same as n factorial?
Correct, yes.
and
Yep,
minus x?
yep.
I'm getting something different from 8 and up.
8 and up,
Yeah.
what do you got?
For 8, I got 1, 5, 1.
Could be, I start cross eye after a while.
I just put it in as a function.
Oh, I see.
Table.
Yep, that's such a smart, I didn't think of that. I like what you did there. I'll explain that. So what do you got for 8?
0.1517.
9,
0.2866. 0.3248.
3, 2, 4, 8,
And 1, 6.
7, 3. So when you add them, that should add up to 1. I like what he did there, so I don't want to retype out this equation again and again and again. So what you do, you enter the equation just like if you were, I don't know how to enter, but I can graph it. Pretend I'm going to graph it. Where's my graph here? Here we go, graph. I can type the equation. I can say 11, math and probability. Where's math? I know I saw it. I was using it. Math. Where'd you go? Oh, math. Probability NCR x times 0.85 to the power of x times 0.15 to the power parentheses 11 minus x, right? You write that equation in, and instead of graphing, I don't want to graph it. Go back to graph. I gotta hit enter first. Go back to graph while you're thinking you're gonna graph it. You don't want to graph it and mode here. Nope. Window setup.
Table?
Table, window setup. Where's table? Then you can put the value for x, but I do as window setup with them. When I go to graph them, it gives you that y equals, which is fine. Then usually they have one to adjust the window, and I put an ask mode, and I put x equals 1, x equals 2, x equals 3, x equals 4, and we'll give you the values.
On the graphing
Yep.
calculator is set to this one.
Yeah, I don't have it on this one. That's what I was looking for. There's one I know window setup. You can go in ask mode, put an ask mode, and you put x equals 1, x equals 2, x equals 3, will give you the answers. But you can get the answers much easier and quicker. Before you leave, the nice thing about this, if you know the event is a binomial, you can find the probability quickly using that calculator. You don't have to spend hours on that. Now the other thing is you can find the mean and the standard deviation. You can find them even easier than the way we did the probability distribution. By the way, our book does it. All the slides will show you how to do them on the TI-84 with a table. Maybe I should look at that. So to find the mean for that, come on, the mean for that mu is n times p. That's it. That's what the mean. So we expect for that flight, n is 11 and 0.85. That's how many people should show up to that flight. That's what we expect. What's that, 10? 11 times 0.85. We expect 9.35 people to show up. So we sold 11 tickets. We expect 9.35. Under 10 people to show up. 10. The standard deviation, sigma, I don't know why I put function of x. Sigma is the square root of n times p times q. So in this case, is the standard deviation be 11 times 0.85 times 0.15. And take the square root of that. The standard deviation is 1.18 for that problem. So it's if you know the event is binomial, you can find the mean, the standard deviation quickly by applying these two equations. We'll stop here. So that's binomial.